Let's talk about caching. In simple terms, caching is when we store some data in a place where we can get to it super fast. It's like when you're studying for an exam and you keep the really important stuff nearby so that whenever you need that data, you don't have to go to the source material. Instead, you have the quick access to that information. In our case, the data is stored in database, and we may not want to fetch the data from the database every single time we need if we are fetching the same data over and over again. This is where Redis or Memcached come in. Both of them are in-memory key-value data storage systems and can be used to implement caching. We're going to be exploring Redis in this episode. Redis keeps the data right in memory, which is faster than having to fetch it from the hard drive. It can handle all sorts of data from strings to lists to hashes, and can also be used to implement other things as well aside from caching, like messaging systems, queues, and so on. So the first thing that we need to do is that we need to install Redis. The installation steps will depend on your environment and setup, so it might be a little bit different based on how you have your local development set up. We're going to install it using Docker since we've been using Docker in this series, but if you're not using Docker, then I would Google the installation steps for your specific setup and try to follow that. I've already updated both the Docker Compose and the Docker files behind the scenes and added the Redis container within the Docker Compose right here. As you can see, we're creating the new container named Expenis Redis and are mapping it to the port 6379. This allows the PHP application to connect to Redis at localhost port 6379. Now my containers have already been built and are running, so if you're following along, just make sure to run docker compose up-d --build. So if I open the terminal and run docker ps, we see that we have the Redis container up and running. Now what we need to do is that we need to communicate with this container from within the PHP. To do that, we need PHP Redis extension or a PHP client. There is PHP Redis extension for PHP, which is a C extension basically, and there is also a native PHP library Redis client called pRedis. You can use either one of them, although the extension is a bit more performant than the native PHP library, but it is up to you which one you want to use. It's easier to install the native PHP library from Composer because it doesn't require you to set up any extensions or anything like that. All you need to do is just Composer require that package. However, I'm going to go with the extension because that's what I usually use. To install the extension, I've modified the Docker file behind the scenes as well. So if we go back to the code and open the Docker file, we see that we have that installation command to install Redis and to enable the extension. Again, make sure to run docker compose up-d --build to rebuild your containers if you're following along and are using this code. Before we connect to Redis from our PHP, I want to actually implement one of the PSRs to show you how you can implement a proper cache class. There are actually two PSRs related to caches. One is PSR6 and the other one is PSR16. PSR16 is a simple cache that provides easy to use interface for caching, while PSR6 is a bit more complex but robust standard. For our purposes, I'm going to implement the basic PSR16 interface just to show you as an example how we can use Redis. To get access to the PSR16 interface, we need to pull in another package, and that package is PSR Simple Cache. So we'll do composer require PSR Simple Cache. Once that's installed, let's go ahead and create a new class here called Redis Cache. And we're going to implement the cache interface from that simple cache namespace. So we'll do implement cache interface from PSR simple cache. Now we need to provide all of these methods and implement them as well. So we have the get method, set method, delete, clear, get multiple, set multiple, delete multiple, and has. Now the way we're going to implement this is that we're going to inject the Redis client class in the constructor. So we'll do construct and accept the Redis client in here. So we'll do private read-only Redis, and this is the class that comes from the extension. So first, to implement the get method, we're going to get the value from the Redis client. So we'll do value equals this Redis get and pass the key. Because remember, Redis is a key value storage, right? We are storing values using the keys, and to get the value, we need to use the key as well. If key doesn't exist, then it's going to return false. Otherwise, it will return whatever the value is stored there. So if the returned value is false, then we can return the default value. Otherwise, we'll return whatever it found. Now you might have a question, what happens when we store false as the value? And by false, I mean Boolean false. What happens to this return statement? So let's think about it. Let's say that we stored false as the value in Redis. When we get that value, we are assuming that false means the key doesn't exist and we return default. But you might expect that it would return false instead. So the way this works is that in Redis, when you try to store a Boolean false, it is going to store it as a string. And when Boolean is converted to string in PHP, false becomes empty string and true becomes 1. So essentially in Redis, the Boolean false is actually stored as an empty string. So this would come back as an empty string, and then this would of course fail, and this would return an empty string as the value. Then let's move on to the set method. So in here we'll do return this Redis set, and we'll set the value at this key and pass the TTL or time to live variable. This time to live variable is basically the time duration after which the stored key value pair will automatically be deleted from the Redis database. Now, as you can see, this variable can also be an instance of date interval, and we need to add some handling for that. So if this variable is instance of date interval, then we need to add that interval to the overall time to live number of seconds. So we can do something like if TTL is instance of date interval, we'll do something like new date time and initialize it using @0, which will return the Unix timestamp for January 1st, 1970. And we'll add the interval this way. So we'll do add and pass the TTL here, and then finally convert it to the number of seconds by using getTimestamp. Let's continue. Next, we're going to implement the delete method, and this is pretty simple. So we're just going to return this Redis delete and pass the key. Now this method returns number of keys that it deleted. So we can add a check here that if the number of keys deleted is 1, then the deletion was successful. Otherwise, it was not. Then let's move on to clear method. Here we're just gonna call the flushdb method on the Redis client. So we'll do return this Redis flushdb, and then let's implement get multiple. In here we need to get multiple values by using multiple keys. And here keys are expected to be iterable. So what we'll do is that we'll try to get the values using mget method from Redis. So we'll do this Redis mget, and we'll cast the keys into array. We'll create a new result variable, set it to empty array. Then we'll do for each values as I equals to value, and we'll do result keys I equals value. And this value, remember, might be false. So if it's false, we need to set it to default. So we'll do again, if it's false, we'll set it to default. Otherwise, we'll set it to value. And finally, we'll return the result. So again, what's happening here is that we're getting all the values using these keys from Redis. Then we are iterating over them, and we are creating a new array using the keys that were given. Next, let's implement the has method. Within the has method, we can just call the exists method on Redis and return that. Now we're left with just set multiple and delete multiple methods that are not implemented. Now delete multiple is pretty simple. So first we're going to cast keys into an array, so this way, and then we'll do return this Redis delete keys and compare that to the number of keys that were given in the argument. Remember that delete returns number of keys that it has deleted. So if we pass an array in here, this will return number of keys that it has deleted. And if that matches the number of keys that was given, that means that deletion was successful. And finally, to set the multiple values in Redis, we're going to basically first cast values to array. So we'll do values cast into array values. Then we'll do result equals this Redis mset, and mset method accepts array, so we can pass values this way. And then we need to set the time to leave for each of these values in the Redis, and we can use the expire method on the Redis client to set each individual entry's expiration. So we can do something like if TTL is not null, we can loop through the keys of the values. So we can do array keys values as key, and then do this Redis expire key and set the TTL this way. Now we do need to do the same thing that we did in here to check if it's instance of date interval. So let's copy that and put it in here. So if the given TTL is instance of date interval, we'll add that interval and set the expiration. Now we do need to cast this to integer because expected type is integer. Finally, let's return the result. Alright, so now that we have all of these methods implemented, let's test some of them out. Let's maybe go to home controller and inject our cache interface in here to play around with it. So we'll do private read-only cache interface cache, and then we'll do something like this cache set, and we'll set key A with value 1, and then we'll set cache set multiple B equals 2, C equals 3, and then we'll dump the results. So we'll do var dump this cache get A, and then we'll also do this cache get multiple B and C. Now for this to work, we of course need to add the entry in our container bindings for cache interface. So let's open container bindings, scroll down here. We'll do cache interface. We're going to initialize the Redis client here. So we'll do Redis equals new Redis. Then we need to connect to Redis. So we'll do Redis connect, and we need the host and the port. Why don't we actually grab the host and port from the configuration? So we need to inject the config in here, and we'll add the necessary entries in our config file, but let's assume that we have the config all set up. So we'll do config equals config get Redis, then we'll do config host cast the port to integer, and we also need to authenticate because we have the password, right? So we'll do Redis auth config password, and finally we'll instantiate our Redis cache class and pass down the Redis instance. So we'll do return new Redis cache and pass Redis this way. Let's import these classes. Now we need to add the Redis entry in our config file. So we'll do app.php. In here we'll add Redis, and we need host, port, and password, and we'll get these from the environment variables. So let's copy this and paste it in here. Host will be Redis host, port will be Redis port, and the password will be Redis password. And as you can see, I've already added these environment variables behind the scenes. So if I open the env file here, we have the Redis host, Redis port, and the Redis password. Now you might be asking why not localhost and why Redis? This is the same reason as we did DB for the database host and not localhost. Basically, it's because Redis is not installed in the same container as our PHP application. It's a separate container, and the service name for that Redis container is Redis, and that's why we're calling this host Redis. Alright, so let's now open the browser and test this out. We'll go to home page, and sure enough, we see that it's working. It's printing 1 first, and then it's printing 2 and 3 for B and C when getting multiple. Let's set this to expire in maybe 5 seconds, and let's set this to expire in 15 seconds. Let's go back to the browser, and we see that the values are still set. Let's go back here. I'm going to comment these two out. Let's go back to the browser, refresh, and as you can see, the first one has been expired because it was lower expiration time. And if I keep refreshing, the other two were expired too after a few more seconds. Alright, so now that we know the basics of Redis and the basics of cache and how to implement the cache class and PSR16 on our own, let's move on to something that already exists. Frameworks like Laravel and Symfony come with cache components out of the box, so you don't have to reinvent the wheel and create these classes on your own. I just created this class to basically show you how some of that works behind the scenes and get you familiar with it so that you know how you can interact with the Redis client directly. We already have Symfony cache as a dependency in our composer JSON right here. However, I bumped the version from 6.1 I think to 6.2. The Symfony cache component supports both PSR6 and PSR16 and has many adapters, so it's up to you which adapter you want to use and which PSR. You can refer to the Symfony cache documentation for more information on that. For now, we're going to go to container bindings and adjust our cache interface entry in here to use the Symfony cache. Now we can use the same cache interface from the PSR if we want to continue using the PSR16. We just need to return a new instance of the PSR16 cache implementation from the Symfony instead of our custom one. And as I mentioned, Symfony does have the implementation for PSR16. So instead of returning Redis cache, we would be returning PSR16 cache. And this basically expects an adapter as an argument. So we need to create the adapter here. So we'll do adapter equals new Redis adapter because we're using Redis. And we need to pass in the Redis client as an argument. So we'll pass in the Redis client because we have it right here. Let's import that and pass the adapter here as an argument. And that's pretty much it. Because we are using the cache interface in home controller, this should still work the same way. So let's uncomment that, and we can actually drop our custom implementation. So we no longer need that Redis cache because we're using the Symfony cache. Now let's go back to home page. Let's refresh the page. And as you can see, everything is still working as expected. Let's go back here. Let's comment these out. Go back, refresh. They're still set. Refresh again. The first one expired. Keep refreshing a few more times. And after a few seconds, these expired as well. Alright, so now that we've played around with it using the simple examples, let's see how we can apply that to our current existing Expanis app. So let's go back to the code. Let's drop all of this. Let's get rid of that. And let's open transaction import service. Within this service, we're fetching all the categories keyed by name. So we're calling this method to get all the categories. And this is something that could be potentially cached because categories don't change that often. And depending on how many times we need to get all the categories and store it in a variable, storing that in the cache might be beneficial. It basically depends on how heavy this method call is, the size of the table, and what sort of performance gain we would get by using caching. So let's go in here and let's inject the cache interface in the constructor. So we'll do private read-only cache interface cache. Then let's scroll down, and in here we'll check if the categories exist in the cache. Then we'll pull it from the cache and return it instead of making the database request. So we'll do if this cache has some kind of key, maybe like categories keyed by name. If we have this, then we'll simply return it. So we'll do this cache get and get the same key. Otherwise, if we don't have the categories keyed by name in cache, then we need to make the database request. We need to run the database query and then store the category map in cache so that next time this method is called, it is pulled from the cache and not from the database. So in here, after we create this category map, we can do something like this cache set categories keyed by name and set it to category map. Now, while this looks good, there is actually a big problem here. And the problem is that we have per user categories and per user data in general in our app. If categories are cached for user A, then any other user would get user A's categories, and that is not good, right? We would essentially be exposing another user's categories to other users. So what we need to do is that we need to cache the data specific to the user. There are multiple ways that we can go about that, and the simplest way in this case is to simply accept the user ID as an argument here. So we'll do int user ID and use that as part of the key. So we can do something like concatenate this with the user ID, and this should be capital. Let's replace that. And we would need to do the same thing for these other two places. Why don't we remove this and store it in some kind of cache key variable. So we'll do cache key equals this, and then use that key everywhere else within here. So we'll do it this way and this way. Now please note that you would have to make sure to remove this from cache whenever the category is updated, created, or deleted. So essentially you would have to delete this cache key from the cache whenever the category is updated or deleted. I'm not going to spend time implementing all of that in here. I just wanted to show it to you as an example. I'm actually going to get rid of this from here because we don't really need caching for this specific category service. I just wanted to demonstrate an example of how this would work. If you're implementing caching for some heavy operations, just make sure that you're caching the data for the proper user, and make sure that you're deleting the cache properly after the updates have been made. Now you might be asking, how do you decide if you should use cache or not? Like, how did I decide that I actually don't need caching for this? The way I go about this is that I look at few key indicators. Number one is the frequency of access. How often do we access this data? Second is how costly the operation is. What's the performance? Basically, how long does it take to execute this query, as an example. And third, how often the data changes. If we keep on updating the categories pretty frequently, then storing that in cache may not be best, because then you have to make sure that the data gets removed from the cache constantly every time you make updates. But if you have somewhat static or data that doesn't change that often, then it's probably a good candidate to be stored in cache. I would say that just make sure you take the security into consideration to not leak data from one user to another user unless data doesn't belong to a specific user. But in general, you should always be cautious how you cache the data. Add necessary prefixes to cache it for specific users, make sure to delete the cache if the changes are made to the data, and so on. Alright, so this is it for this video. Thank you so much for watching. Please hit the like button and subscribe if you enjoyed the video. Until next time, happy coding.